So question 1b, John has been reading up about the Space Telescope. Its main mirror is made up of smaller hexagonal mirrors. John starts drawing out some patterns of the hexagons, some are drawn below. So that's the pattern, and they've started doing this table. If you can see, what's been added on is there's another row of hexagons added on there. So the next row will have an extra 5, the next row will have an extra 6, etc. Okay, so we're going to add 5. So this difference here is 3, this difference here is 4, this difference here is 5, so that's 14, and that difference here is 20, because the difference is 6. So now we need an equation that represents a number of hexagons. Okay, we know it's not linear because it's not going up by the same amount, but we know that it is a quadratic because that second difference is common in that there. Now what we do is we take half of that common second difference, and that goes in front of our x squared. Now we've got to find out what goes on the end to make up the rest of the equation. This is for part 2. Okay, so what we do is that we go, right, okay, let's put our 0.5 times x squared here. Okay, so we've got 0.5 times 1 squared, which is 0.5. 1 times 1 squared is 1, half of 1. 0.5, I'm just going to call it half. So 2 squared is 4, half of 2 is 2. 3 squared is 9, half of 3 is 4.5. 4 squared is 16, half of 16 is 8. 5 squared is 25, half of 25 is 12.5. Okay, so now we've got this bit. Now we're going to work out what do we have to add on to get to this bit here. So this difference here is 1.5, from 0.5 to 2. From 2 to 5 is 3. From 4.5 is 4.5. From 8 is 6. And 12.5 to 20 is 7.5. And can you see that there's a common difference in here? And that's like a linear pattern now, okay? And that common difference is 1.5. Okay, so we're timesing n by 1.5, our x value by 1.5 to add on to that. If we times 2 by 1.5, we're adding on the 3 to get the 5. If we're timesing 3 by 1.5, we get 4.5, so we're adding that on to get the 9. So our add-on is 1.5 times n. Oh, sorry, x. We'll keep it the same. Okay. Sorry, they said n. You should keep it, check to see that you've got the same letters with it. Okay, part 3, use the axis to draw the best represents the relationship. Okay, so all you're doing is doing the table. Now, we've got x and n, so our first point here is 1 and 2. 1 and 2. Our next point is 2 and 5. Our next point is 3 and 9. And then 4 and 14, and then 5 and 20. Now, then you make the decision, do I join them up or not? Can you have 1.5 patterns? No, you can't, so therefore you just leave it as crosses like that. And that is question 1b.